Hi class, I wanted to do an example of similar triangles that you see very often in chapter 17. A 13-foot tree casts a 12-foot shadow. A man 8 feet from the tree casts a 4-foot shadow. How tall was the man? Now rather than asking the man how tall he was, let's see if we can use similar triangles to solve this problem. We always begin by drawing a picture. So in my picture, here is our sun, our tree, which is 13 feet tall, our man, which we don't know his height. We know that he stands 8 feet from the tree, and he casts a shadow of 4 feet, for a total of 12 feet here, which is the length of the shadow of the tree itself. I then break this into two right triangles. For the tree, we have 13 for its height, 12 for its shadow. Now technically we could use the Pythagorean theorem to find the hypotenuse measurement here, since a squared plus b squared equals c squared, but let's see if that's even necessary in this problem. For our smaller right triangle, we notice that we have an unknown height for the height of the man, a shadow length of 4 feet. Okay. Now we'll use our information from both triangles together to form a ratio for each situation. For the tree, we know that the height is 13 feet. For the man, we don't know the height, so we could use maybe x. So we'll call the man's height x. Okay. For the shadow, so this was for the height. For the shadow, again, we did the big triangle over the small triangle. Let's be consistent. For the shadow length, the big triangle had a length of 12, and the small triangle had a length of 4. Now we have two ratios, one for the height, one for the shadow. Big over small, just being consistent is important. Let's cross multiply. 13 times 4 is 52. X times 12 is 12x. Dividing both sides here by 12, 52 over 12 gives us x. Knowing how to reduce this is important. 52 cards in the deck, so there's 4 suits of 13. So 4 goes into 52 13 times, and 4 goes into 12 3 times. In other words, 13 over 3 is the height of the man, but 13 over 3 is really 4 and 1/3. So the man's height is a very not so tall man at 4 and 1/3 feet tall. Okay? So that gives us an example, a very simple example, I hope, of how we can use a situation of similar triangles or similar figures to solve a word problem in geometry. I hope that makes things a little more clear for your 17.3 homework, and I hope that with much practice you can become a professional at these types of problems. All the best.